Let's turn the mic on. We should be here. Okay, so it's New Year's Day. Really easy stream, he says. He whacks out a massive technical manual. You shouldn't be focusing. You should be focused. Quick check on the camera because that's going to irritate the hell out of me. No, that is set to solid to no change on the focus. So we are building a computer today. We are building a clone of a Jupiter Ace. For those who don't know what a Jupiter Ace is, play the game. Do a window capture. This is a Jupiter Ace. Courtesy of Yoldi Wikipedia. It is a microcomputer that was made in the early 1980s. We had so many microcomputers from the 1980s. The big difference between this and almost any other microcomputer from the 1980s, a British microcomputer from the 1980s, is this one runs Forth, a stack-based language, as opposed to BASIC for its native language. They are relatively rare, and they are a bugger to maintain, or so everybody tells me they're a bugger to maintain. Only a few thousand of them were manufactured and distributed. They've become relatively popular for people to play with now. I fell down a small hole playing with Forth last year in emulators and various other things. It's quite an elegant little language, but I'd quite like a machine to play with. Got an opportunity to pick up one of the kits just before Christmas when Future Was 8-Bit was selling them off. Grabbed it. Today's as good a day as any to build it. So that's our plan for today. So build an Ace. Okay, get rid of that. It comes like this. We get a pack which contains a motherboard, a set of chips. We get some component packs, so a whole bunch of resistors, capacitors, stinky caps, diodes, crystal, a whole bunch of toys, switches because headers, composite port. We've got the capture card set up and ready to go on composite, so we can test this once we've got it all wired up. And an audio jack. Well, the drawer with all of the audio bits is next to me, so we can use that. Little tack switches. All of the tack switches. These have bigger posts on than I was expecting. Monsieur, you spoilers with your tack posts. So we might be able to 3D design some actual buttons for these later on, which would be nice. And then some header stands. It comes with this excellent manual that we are going to have a quick flick through. This is our Bible for the next couple of hours. We are not deviating from the Bible. I've had a look at there's another 75 of where are you? Go on camera again. There is yet another DC-DC converter in here. Oh, it's in the main bag. Yeah, 7805 in here, which might be tempted to switch it out for one of our, depending on how hot it runs, might be tempted to switch that out for one of our fancy ones, but they're currently out in the garage. We are streaming from the main desk. We are not streaming from the garage. The garage is not ready for streaming from yet. It needs a big stinky bit of Cat 5, so we are doing soldering from in here. We'll finish off the coffee before we start handling the leaded stuff. So, great manual. Ring bound, feel very much like the Specky manuals. It's just nicely put together. I've got a number of manuals now from systems that I've collected. These are nice. Please, more of these. These are great. Unpacking instructions, assembly tools, and then our instructions for the Minstrel 4. So thank you for buying a Minstrel kit. Most people who build these kits find they work the first time. Verify the contents of your kit before starting assembly. The parts list shows all components and quantities provided. We have spares for pretty much everything, I think, and it looks like it's all there. So, yeah, it's rude, but I'm going to hope and pray. Like an IKEA kit. Do not remove components from the bags until you're ready to install them. So how are you supposed to verify that you've got all the bits if you're not ready to install them? I don't know, but I'm going to go with it anyway. Sorry, mildly confused by something in the chat window down there, nothing in the chat window up there. Let me check to see if... Hey chat, are you working? Yay! Chat is working. Good. I'd like to keep my eyes on one spot if I can rather than 15 spots. So that's good. Use grounded anti-static wrist straps if possible. I do not. I'm a guy who builds machines and I still do not own an anti-static wrist strap. To remove the risk of electrostatic buildup when working with vulnerable components. Minimum tools. We require a soldering iron. Behold, today is a hacko day. I have left the pine cell in the garage until we work out what's going on with power supply issues. And we're going back to the trusty hacko. This is an absolute rock of a soldering iron. FX888D. Had this for a good few years now. It does not go wrong. It is, God, my baby. It's just not very portable. It's not massive, it's just not massively portable. So dragged it out from the garage out to here for today. Rosin core solder. Recommendation, 6040 leaded. Smell those leads. We've gone with leaded for today. We do not have a solder fan. I'm going to print one from upstairs. My current one is dead, and I've got a 120mm fan sat upstairs ready to play. So, screwdriver, Phillips number 1. I have... because there's nothing that says overkill than bringing out the shiny tool set. There should be something that works for a number 1 in here. PH1. This is Jacko's fancy screwdriver. He says, you don't need one of these. No, you don't need one of these. But they are rather nice. And wire cutters. We've got wire cutters back in the stack of doom. These engineer cutters and little pliers are absolutely lovely. If you are looking for cutters and you are looking for mini pliers, engineer ones, bloody nice. Additional tools, continuity checker. We have a multimeter off to the side should we need it. This does continuity. Headband magnifier or magnifying glass. We do not have a scope to hand, so no we don't. Solder wick. We have our solder wick and we have our solder sucker. I tend to use this rather than the solder wick because the solder wick's terrible. And the anti-static wrist strap, which we do not have. So, let's... Yeah, teaser. They're coming out with a new kit. These are the last editions of the old kits. And I've been really good and not just bought one of each, despite it being awfully tempting to get a Minstrel 2 and Minstrel 3 as well as the Minstrel 4. But Minstrel 5 is due next year. And Z80 and a Z81 are still relatively easy to get hold of. That's not too much of a problem, whereas a Jupiter race is a bit more tricky. No idea what they're planning for that, because these tend to be the Z80 based machines as opposed to the pets, etc., that get their own naming and their own lines. So they have their own naming conventions. So awfully curious what we're going to get next year. Right. Let's have a look. Let's have a look at what the 4th looks like. awfully being good at this, I have gone through the instructions, honest, and read through what needs doing. Cappies. 222 picos, 247 picos. Whew. 1800s, 1-1. Yep. One axial electrolytic rated. There you go. Yep. 25 volts. Keyboard overlay, mainboards in the main bag. Seen those. The pack of nylon pillars is here. Resistors. Lots. 16 of those, and shed loads of everything else. If we need any more, that'll be out in the garage. Semiconductors, 9 diodes. Yep. 1 NPN transistor. That's the one thing I may not have spares of, but it's there. 17805, which does not require a heatsink. Well, good for you. Why don't I believe you? No, I believe you. It's in the main bag, which seems odd when everything else isn't. It's there. 1 crystal. These are the crucial bits. Bits we do not have spares for. Saw the crystal. Yoo-hoo! Where are you, Mr. Crystal? There's Crystal. And then a whole bunch of ICs. They lovingly put these ICs, you can see the way that they're organised, to line up with the main board. And the fact that these are all out pretty much tells me that they are here. They use a cheat. But it's a loving cheat, so I'll let it fly. Come on. Okay. There's our keyboard, which is not going to be easy to type on. I've got plans for that later. Huh. Oh no, that's the overlay for the keyboard. I was going to say, how does that interface with the... It's the overlay. Wow, chicka, wow, wow. Look at you. Oh, fresh. So the sockets are in position. Not everything is socketed. Okay. I've got spare sockets. I could socket everything. No, let's be good. That's the heatsink for the 7805. You lay it down and it will heatsink itself against the board. Fine. But on our chips, on Z80, they use an 80 mel, 80, I would say 80 mega, but it's not an 80 mega, is it? They explain. They don't use an original chip in 1 or 2 of these because they're not available, so they use new replacements. 74H C 0, yep. HC21, yep. 32, yep. 74, yep. 86, yep. 166, yep. 254. Yep. 251. Yep. 367. Yep. 574. Yep. 1Z80 CPU. Yep. 128K of SD RAM ASC. Yep. That's the RAM. 2K dual port SRAM. IDT. That one. Pre-programmed CRTC microcontroller. That's what the AT... It is an AT Mega 48p. No, it's not. Oh no, it is. It's down there. AT Mega 48p, 20pu. That's an EP-ROM. There we go. That's the EP-ROM. Whew. Okay. Other parts. 2 stereo 3.5mm jacks. Yep. Phono jack. Yep. And 1 DC jack. No Washington jack. Sorry, bad gag. This looks like we have everything. Okay. Oh! Today's the kind of day where you could do with a bigger desk or working in the garage. Oh my god, we're still going. 40 switches. Yes, I know. 1 miniature short white tactile. I've seen you. 1 piezo. Not a buzzer or any sounder that has internal circuitry. What? Hey, afternoon! It's computer building time. Headers with jumpers. Yep. And a big old bus. So this computer can interface with the 2014 standard components, which makes it fun. Ooh! It's single depth. I thought it was double depth. But yeah, it'll work with fit if using RC 2014. Yeah, damn right we're going to use the RC 2014 stuff with this at some point. 10-way connection for RC 2014 enhanced bus. Interesting. 48-pin. Oh! We're already knocking the camera. 48-pin IC socket. 140-pin IC socket. 130. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Part placement on the Minstrel 4. Yep, that looks as I'd expect it to. That makes perfect sense. These are beautifully silkscreened. Look at that. That layout is excellent. Hey, what? It's easier than an Atari motherboard. There's quite a few passives. It's not horrific, but there's a few passives. Oh, it's similar to like a Specky style keyboard, Specky style motherboard in terms of passives, count of passives, as opposed to as opposed to. I mean, the Atari is not actually that bad for working in terms of passives. It's just that the traces are so bad and they rot all to hell. You breathe on them and they break. Okay. Cool. So, resistors, capacitors. I know you haven't told us to actually place anything yet. Unsocketed ICs and crystals. IC sockets and the reset switch. Is this the order we're supposed to be adding stuff in, folks? Transistor voltage regulator and electrolytic capacitor, piezo. Jumpers and bus. Okay. Ooh. You can make it speedy. 6.5 megahertz. That still looks like ants. See if I can get the focus any better on the manual. Keyboard 6.5. Is that any better? It's as good as it's going to get off this camera, unfortunately. Behold my new typing speed. Power clarity, jacks, keyboard assembly, socketed ICs, and then hello world. I mean, none of these have a great rollover. You met a Specky's keyboard. Okay. Let's go back down to resistors. Resistor placement showing the letter K between numbers are a compressed notation. Okay, I'm going to take these. In fact, before I lift that, I'm going to be the cheekiest bugger in the world. Since they were so nice to provide an easy layout of where those are supposed to be, I'm going to grab a quick photo. And then stack. Okay, move those out to the side. Following board drawing shows resistor locations. Okay. All the resistors, all the resistors. All the resistors, all the resistors. Can I get a whoop, whoop, whoop? Oh. All my resistors. All right, you go back over there. Let's go find something. I did have something chilly and ready to go. Go check. You're ready over here. Okay, audio input output capture, audio output capture. I'm going to be rude for a second and switch screens. Okay. There we go. I quite like building kits. I like building kits with a purpose. Definitely like building kits with a purpose. Let's make sure we're out of the way. Music's louder than the mic. How about in the middle? This is telling me that I'm louder than the music. You do not trust OBS's audio mixer. that should help as well. Helps if your mic is not behind your head. Right. No problem. I've been looking at USB audio input devices and mildly crying. It's been, well, what I need is something that can probably capture 2 to 3 MIDI devices plus like the output from the MIDI devices. Let's get this right. Yeah, capture the output from at least 2 to 3 MIDI devices, probably one computer at the same time, maybe and a mic. It's like, so how much it's right? So I'm going to need to spend that much. That's a terrifying amount of money. Oh, and provide separate audio channels into the computer. Oh, these are separately numbered. Right, let's try not to lose the number. There we go. Right. Let's get that dried. Let's turn you on. But yeah, I like a kit. I also debated using the MT32 for the audio today, and then realised I need to steal its power supply. Like, we could have a DOS box playing MIDI files in the background and just keep it in the top left-hand corner, and then pump it through. It's like, but the power supply for the MT32 is the one I need for this machine. No, I don't need more than one switching centre positive 9-volt power supply. Centre positive or centre negative? Shit. The one that's in the back of the MT32 anyway. Right. 380. Yeah, 380 is fine for this. I've got thingy temperature stuck in my head from upstairs. I'm currently printing PET. Right, what do we want? We have a whole bank of 10Ks running 1, 2, 3, 4. Just cleaned that and now I've touched it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12, 13, 14, 15, 16, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Do they give us spares? Who am I going to trigger if I don't make all of these the same direction? I suppose now's as good a time as any to try this thing. the ball. Home printed bender. Yeah, I've had this for years, but I rarely use it because usually if I'm just doing one or two, I will use pliers. Because why wouldn't you? But since I have a few hundred of these buggers to fit today, why not? Put it on screen in a second. So yeah, I've got a couple different lengths, different sizes, but to be honest, most of these kits seem to need me just to play with like this kind of size. So often it's like, how small can you go? And so 10 before soldering is faster. I can't argue with that. I mean, there's nothing stopping me. How many more do I need to do? 2 on this side. What tends to happen is slow-ass bastard starts slow-ass and then gets faster as he goes along, as he remembers how to do things. I also like to think of this as the warm-up. Codes are terrible, so 100 nano, 100 NF, 200, 220k I should be able to identify by frickin' sight because I use them constantly. Ah, of course. Right, what does it want next? It wants 100 NF. Really? Well, 220. Red, yep. Yellow, brown. Oh, red, yellow, gold, sorry. That's you. That's your 220. I'm not wrong, that says 100. 100 nanos. Farads, Ian, farads. Not K, farads. Oh. Hey Kim, why can't you find the 100 nanofarad resistor? Yep. That can be a bit dense, right? We'll come back to those. Okay. 220k, so 2 caps for there. Top left, 2 10ks. Run away. The F is indeed important. So 2 10ks top left. Got that? Probably not. I've got somewhere the tiniest freaking surface mount component I ever had to solder. It is. I can't remember what it came off. It came off of a toy of some description. It was one of those that, you know, oh, thing fell off. Oh, you got to get it back on now. Oh my god. you know the scenes of, if you cut the wrong wire, the bomb will explode. Really was hold with tweezer, tap with iron, hope for the best. Couldn't flood it because it just floated off like it was a freaking raft on a river. It was a cat toy. It was a cat toy. The girl's favourite laser pointer toy. And the shaft with the laser point mechanism had the tiniest cap. It was a cap in the end of it. Just on the end of the shaft. And it just, as I was repairing it, it floated, it detached. It's the kind of thing you go, anything but that, bump. It's like, fuck, I've got to get this thing back on again. Oh, like no, I am going to repair the £20 cat toy. We can order another one. No, we can't. Still at the repair. It broke again because it's so badly designed. They keep asking for it. I know. It broke again and it needs repairing again. And I dread going back into it because it's such a badly designed piece of crap. I added strain relief to it to avoid the problem. Red, brown. Gold, sorry. Red, gold. 2k2. $4k7. Yellow, purple. Yeah. Yellow, purple. Yep. No. Yes. Yellow, purple, red, gold. But I built, it's like, let's repair the cat toy. Build strain relief into it. Make sure the solders are, that all of the connections have been jacketed. Moved here, broke again. It was clearly a toy that was designed to die. 75 ohms. An odd value. Purple, green, black. Well, we've got two of them. Purple, green, black, gold. Oh, that sounds fun! Please tell me more, Fingers at Mums. Please tell me about the Robot Wars spin-off. I mean, that genuinely sounds amazing. Okay, that line is in. Two, three, four. Not that one. Well, I've got to remember not to stick my head underneath the freaking camera. 2, 3, 4. They look good. Top for the common drive module. Ah, nice! With arms and a head. Oh, that does sound fun though. Good grief. That's the kind of thing I would have killed to have had an opportunity for. Grabbing and paintballing challenges. Sadly, my machine blew up the armator controllers. So good. Right. Don't need you two. Brown, black, red, gold. 1K. Starter for 10. Another 10. Yeah, I think I, like a lot of geeks my age, idolised Robot Wars and its ilk, but never had the opportunity to really capitalise on that. 470. Is this the last of our specials? Yes. Well, let's check it. Yellow, purple, brown, gold. Yep. I used to be able to read resistor codes off by heart. Now I've got lazy. I don't mind. Yeah, key geek influences for computing and making stuff. Robot Wars is pretty freaking high on the list. God, I struggle to think beyond that. Just seeing people building robots and, like, I mean, yes, it's mechanized destruction, but the stuff that was going on in the pits week after week, I think that was more influential. Jack. You, my machines have fandom pages. Oh, that's amazing. You're not there. You can see it. That means that you've created a thing that lives on beyond you, and that's a good thing. Yeah. That, sir, is legacy. I mean, you also have children for that, but you know. Okay, all of our resistors are in. Orienting to align color bands is for aesthetic purposes only. No, resistors do not work if you put them the wrong way round. If the color bands are opposite sides, they do not work. Where's my clips? I think we're safe for clipping. Quick visual check before we do. Do we get our caps in first? I just feel like it's a point of no return. Oh. I don't have a tin. Forever famous for being flung across the arena. Oh. You're gonna name drop something and I'm gonna lose my freaking mind, aren't you? Let another bot flip off the power switch. I totally remember that. Buzz Ant TNG and Legion Ant weights. Fantastic. Well, that's our first ones in. Buzz Ant the Next Generation. Neither of those names ring bells, unfortunately. However, you know I'm going to go back through YouTube history now. Right. Ceramic capacitors and diodes. Oh. Stinky caps. No, these aren't stinky caps. These are caps that behave themselves. Well, I'm panicking. Oh, shit me. We aren't done with resistors. Oh, frickin' hell. Breathe. Behold, a whole bunch of 10Ks across the bottom. It's like, why have I still got a bunch of 10Ks? Still got buzz amp, probably still works with a fitting new radio receiver. I mean, this feels like an opportunity for something, at least good content. At least a good weekend. 1, 2, 3, 4, 5, 6, 7. All the diodes the same way? Yes. Ooh. Nearly made a mistake there. Resistors don't work if you put them in the wrong way. It would be pretty cool to meet Buzz Ant at some point. Playing with fighting robots is definitely on that list of things to do before. So, I have a slightly tongue-in-cheek list of things to do before they die. Which is usually the list of things to knock off my list before the other side becomes incapable of doing so. So one of them was things like sort of layouts of diodes are the same way. Yes, agreed. Then you get a pain in the diodes all down the same side. Yeah, having effectively a list of things that you realise these experiences can only be done within a certain limited amount of time because they're rapidly becoming unavailable to you. So I realised that certain radio people would no longer be around, so I'd have to go and see them sooner rather than later was the classic one. Certain performers also fitted into that category, although some of them turned out to be less fun, and I've now re-evaluated that situation. Oh, okay, that sounds cool. I mean, the ultimate idea would be to go and freaking enter and play. But that means having a little more capacity to do so. I don't know, post Iron Man? There's a hack space in Lee. And I'm curious what they had to they shut down basically completely over the course of COVID. So I'd be immensely curious what they get up to, if that's something that would be remotely on their radar. Sometimes odd to not think of ourselves as exactly Bolton anymore. That's better. That's not bad. Okay, now the resistors are done. Okay. Now we panic less. Featherweight combat robots without the weapons. Yeah, makes sense. I'd be curious to know what the schematics for those look like. Or, you know, just generally how they operate. Those are bits that were, I think, missing to me for accessibility was how the hell do I get from point A to point B? I can build stuff like this, no problem all day. And this tends to be, I can do some mechanical bits, but I'm definitely on the electronic side of the fence. But breaking that barrier, I think, between electronics and mechanical, I think that's what gets interesting. Yeah, you should be able to post a link into the chat for if you're willing to that, or WhatsApp me, that'd be okay. No, ceramic capacitors do not have a polarity and may be sold in either orientation. Okay, so I'd be tempted to do the diodes first because they're flatter. Where are my diodes? Diddy diodes! So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Go on, where's the 9? 9. Fair. I believe you can write you can build an alternative keyboard interface to this. I'm super curious about doing that. Before I actually built the machine. It's like, planning a replacement keyboard before I built the machine. That's entirely me. What? 2. No, no. 3. You want to live? 4. It's not exactly center, it's gonna bother me. 6. 7. 8. 9. And at the top. Three. 4. 5. 6. Better come down. 7. 8. I think that was my phone going off. Gonna assume that was you, Richard. It was. Oh, those are cool. Okay. So, 2 geared motors. Mind if I share that? I think that's pretty cool. Is a pair of motor gearbox assemblies from battery drills. I don't know if this is going to work or if I have to do extra work. Let's find out. Oh, fuck's sake. Save image. Don't copy image. Save image. Download. There we go. That's really cool. Yeah. Remove the chuck, screw on the wheel. $12 volts, 24 volts. Because those are 3D printed housings, aren't they? Answer, yes. Are the wheels 3D printed as well? They look 3D printed. Those are excellent. So I'm going to build one now. Add it to the queue. Add it to the queue. Add it to the queue. ABS with keyed rubber tyres. Nice. I've not tried printing ABS yet. I stopped at PETG. I just had a disastrous experience with, oh my god, 2 rolls of PLA from a particular supply. I think I posted some of the pictures in. Yeah, I did post some of the pictures in chat. There's nothing quite like knocking your confidence like there being an issue with who you're getting your supply from. Ah. One has shattered. Wow. That's impressive. I mean, usually you just go ABS is the top of the food chain. Okay, I'll turn that off for the minute. But that is cool. That is actually cool. Right, where was I? Got a lot of legs. get these in. I mean, diodes, yes. For fun, I've turned them around, so some of them are forward, some of them are backwards. I think they look funkier that way. There we go, they're all in. Mr. Clippies. No, do the caps first. Ceramic capacitors do not have an orientation. Oh, I can. But. Let's see. I definitely need more light. There we go. I am giving my eyes a break. You still not worked out how to disconnect Streamlabs. Streamlabs says it's disconnected and it's still posting into my bloody chat. Okay, ceramic caps. $104s. God, I should know what. I spent forever. Hundreds. We have 1800 nanos. They are all over the shop. Literally, look at that. It's a lot. As there should be. These aren't a cleaner pull as the everything else has been. Come on. Be good for me. No! Fallen comrade. Yep. Right, well, hey you, I'm sorry, you can't jump up today. We're doing hot things. No. No. Just come in. Thank you. We need to place these as we go, I think. 100. Interesting. Fair enough. These are narrower than the gauge on that one. It's thicker. No! We're gonna need needle nose. Okay, first one in. Second one in. I'm assuming these are all being used as 100 nanofarads for decoupling? No. Well, that was an ugly pinch. Let's try that again. Yep. God, that's terrible. Use the bender for that one. Yeah, you're right. I also realised that the ones I've already pre-bent, I haven't done the important bit of putting the code towards the front. Is it important? No. Is it going to irk me? Yes. Oh, for fuck's sake. You said I could use the bender. Turns out it's not quite a standard distance. Look, I'm going back over my own self-determination to carefully. Missed 100. Too short, isn't it? What's that on this run? There's 3 more to correct. It's not like we're in a rush. Only 572 more components to solder. Ooh. Luckily, the components they've selected for these kits seem to be quite nice. I've had some with legs and that are so thin and crap. That they just don't take any reworking. Okay. Read 'em. Zip 'em. Glue 'em. Video. Okay. Okay, first round. Oh. Of caps. I was missing an adequate collection of legs for bridge repair work. Seem to be fixing that problem pretty rapidly. Come on. There we go. Right, so that's our first round of hundreds in. We've got another 4 going across there. Another 100 there, so 1, 2, 3, 4. 5. Another one there, 6. Rest of you. Oh, 1, 2, 3, 4. Leaves one hidden one. 4, 5, 6. It's going to come out in the rock wash somewhere, isn't it? That should be standard pitch distance, so... That one should... Nope, not that one. That one. Should be easy. Yep. Okay. You could work if I can get you to bend at this position. Let's find out. Like you should. Okay. Yes. To use the one that didn't make the point. These would look fun, tell me they're all the same orientation. They are. Another 100 in the bottom left. Yeah, it's bigger. It's bigger. It's back to the previous size pitch. What compounds it are is I could have used that one up here and left this one for a different one, but never mind. Go big or go home. Or just, you know, go home. There we go. Which leaves those three. Nice. And them first. Ah. You are home. Well done. That explains the mystery of where the missing 100 nanofarad goes. We're almost at the end of the hundreds. Go. You down. You are loose. Three down. 1, 2, 3. Yep. Nope. Five. Six. 7. 8. 8. Yeah, I don't need you. You go away. Tell me, Mr. Anderson. You like heat? Ow. Super not happy with how that one came out. In there. There we go. Okay. They are in. Oh. Trim those down. To replace my clippers. These have been great clippers, but I did manage to damage them and they've not been the same since. And I'm definitely up to I'm holding on to these! I know how much better they can be, so really I should just go sod it and get another pair of them, because they are excellent when they're behaving themselves. So yeah, I should just bite the bullet and replace the bloody things. Okay, so that's starting to look better. Oh, stretch, stretch. Oh. We've still got a few caps to go. A few ceramic caps specifically. There's a bloody big one there. So, 3 individual ones. And 2. So, I'm going to guess those 2 are 22s. Since they're the same. And they say 22. So, that feels pretty on the mark. Yeah, 220, 220J. So those are my 22s for the top left. What else we got, folks? 247s. That drew me. We have 247s and a one micro. So is this my 1 micro? As I keep turning it around, it keeps ending up the wrong way around. That's my 105. Should be my 1 microfarad. Yep. So 22s, 1, 47s. Yep, 47s. Okay. 47's bottom left in our standard-ish array size. Well, 2 down. So we'll go grab those. We want 2 of those. There's where the 1 goes. 47, 1. (47) 2. Those are right. 22 picos top left. Whew. Not many passives, he said. Still not many passives. Still feeling them. And the 105. Okay, 1, 2, 3, 4. Isn't it? They look almost okay. That one I don't like. Well, we're not touching that one because apparently I've already trimmed it. But the others look fine. Collect those. Nice. Okay, ceramics, done. Diodes, done. Resistors, done. Unsocketed ICs and crystals. Sound check complete. Crystal first. Crystals do not have polarity and may be soldered in either orientation. I feel like the word should be pointing in because all of the other words should be pointing in. So let's do this one first. Ooh. Grab a chip. So the 74 HC74N not. Dalton Fiddle McLovin. IC's first, then crystal. I usually end up rolling these. Everything these sockets. That feels a long way from the IC, but it is quite slow. I'm not sure I quite grok you. There we go. Okay, 74. 86. Now, if I remember correctly, these are laid out in such a way, yep, that they should translate straight on. So that's the 74, this should be the 86. Yes. I hear you. The Z80's over here. The crystal's over there. It's like, huh? would expect that to be a bit closer, wouldn't you? Two. That's how I used to do this. Very friendly, yeah. Wasn't there a trick for lining up all of the pins at the same time? Yes, Kian. Little resistance, but not too much. There we go, 86 in. I feel like I'm being too gentle and yet at the same time. 166. Five, 7, 4. 7.4. Fired from an iPhone factory. So close. Okay, let's start with those ones. I want a piece of paper that does not contain sensitive information. The irony is a piece of paper. Oh, that's stupid, that's not going to work. This sensitive? No, this is not sensitive. I'm not even sure whose this one's from. That's got an address on it. That's from Cool Novelties. Oh! It's a piece of paper for interconnects, etc. Right. Now, just one of those to start with, and then check. It's all of them. Be a little more flush. Maybe they can't. Maybe I got them as flat as they were going to go. Yeah. Okay. Okay, you're touching the board again. That one's not in. It is now. Okay. Yeah, let's do them by block. Otherwise I'll lose concentration. So that line going down that side is part of the S video route. So we are on here. 1.5 chips down. Cool. You can go straight up here. Hey, back we go. Okay, just leave that one run. That's done, that's done, that's done. Yep, check, check, check. That one and that one. Yep, 3 down. Got the bank across the bottom. That should be 00, that should be 74. That should be 32, that should be 251 again, and that should be 367. Hey, here we go. Two. Four. Nice on this one. Right, here we go again. Go check those, make sure we're happy with their placements. Yeah. Happy with those. Run some gates. One, 2, 3, 4. 4, 5, 6. 3, 4, 6. Feel the heat off the iron. Maybe the fingers are a little too close to the edge of the solder. Close. Oh! Oh! Okay. Let's see that one. There's a run down here we haven't done that, but we'd already got, and we have not. So. Quick inspection. Yep, they look okay. Okay. 2 unsocketed ICs to go. Ones in the middle should be a 32 and a 21. 32, 21. You really see it starting to come together. There's 2. Might get away with that. Might need a bit more rolling. Use the sheet, Cam. Use the sheet. Okay, these two in the middle. Oh. You change the tape. And both those? Yep. Quick check. Yeah, they look okay. Now. I do not want to admit that magnifier glasses might be a good idea. This work. I also don't like getting much closer to the screen, to the workpiece. All right. Ow. Crystal. Quick visual check of those. Yeah. Crystal. We agreed words would go in to match the orientation on the board. Yep. Spring. Useful. Well, the nice thing is, this is the only bit of clipping we need to do. Cutters get in. There we go. Oh! Okay, so unsocketed ICs and crystals are on the board. And it's starting to look like something, which is good. IC sockets and reset switch. Align the IC socket notch with the notch on the board image. Yep. So I did this, so they should all do that. Almost planned this. There we go. Notches. Okay. Socket 1, this is socket 2. Is it 5 sockets? Have I got my bullet? I do, just in case. 2. 3. 4. What have we missed? Nobody, apparently. It's sus. Are you all on the deck? Okay. They do all appear to be on the deck. Okay. So we can solve it. I thought something felt odd in the cable. I managed to twist it. One down. Well, two down. This is the third one. Sockets down. The cost its weight in solder alone. Okay, 4 sockets down. Active socket on the end, yep. Ooh. Some of those jokes felt lazy. There we go. Just at a point where you know you're not fine. You know they're okay, but they could be tidier. So, okay. Whoop! Don't melt your power cable. Do not melt your power cable. Focus. Okay. Yeah, I've got 4 balls. Ooh. I think we're there. Okay. And the reset switch. I noticed we still haven't done the axial. Also, axial! I get hold of those for love and fricking money. All of my recaps are being done with thingy caps, just differently aligned. Now I know the reset switch was in here somewhere. Oh god, switch. It's white. It wasn't in the big bag of switches, because that's for that. It's not in the motherboard bag. There it is. Reset switch. Okay, legs to the left, frog legs to the right. Put through. Yep, we're good. Lovely. Next page in the manual. 69. I'm allowed to be childish. Oh, transistor, voltage regulator, and electrolytic capacitor! Finally, the stinky cap. Okay. Transistor orientation. Two components in there. Align the flat edge with the flat edge of the image on the board. There it is. Okay, transistor in. Let's do you first. Okay. And nudged. So that's the transistor in. Position the voltage regulator as shown in the picture above. I haven't seen a screw for it. Yeah, bend legs with pliers at 90 degrees where they narrow. So grab that, bend here. The same as on everything else. So that then lines up to here. Trust that is about as far as I can throw it. No, I don't, it's fine. I would just prefer it if it was actually anchored. Hot. Is usually the kind of trick I'd end up doing. So screwing it down, either soldering it through, something. But just 7805 that just sits there when I know how hot these things get. I've blown two of these, not the boards, 7805s. I switch my old boards out now to switching regulators. I don't leave them with 7805s anymore. but they're also highly inefficient boards, and this is a new design board designed to replicate a Jupiter race. It's not exactly a Jupiter race. I mean, I should be able to switch out the 7805 directly for the switching. So if it bothers me, we can check the heat as we go. And if if I don't like what I find, I can switch it out. I've got no qualms whatsoever about just switching it out. But yeah, there's no pad provided to act as an intermediary. It's just, here's the board, here's the sink. It's the one thing I'm a little twitchy over. is high. So hot it unsoldered itself, still worked, they're tough. The ones in the Spectrums weren't. Might be a generational thing. Right. Capacitor orientation. Observe the polarity of the 22. Yes. Yes. Oh, who pre-bent that badly? Oh. Right. Straighten you out and then put you in the right way. Also, if I want to put this in a case, maybe I want to run it hot. That's the other side. Especially if I want that case to be made of PLA. So... yeah, negative that way. Where is it? It's over here. Have you met the modern switching replacement? I'm guessing you have. But have you met the drop-in replacements for the 7805s? They've become a bit of a darling for machine repairs. I'm happy with that. Okay, piezos. It is. They're not cheap. They're a few quid a piece. So I keep a couple of them around. But only a couple of them around. I put one into the Cura, obviously one in the Specky and one in the Cura. The Cura runs surprisingly hot. If you've got new designs, it's great. It's when you're working on the old hardware and you're trying to... I don't mind replacing... I'm not too much about keeping it museum quality. You know, if there's an improvement to be made, I'll make it. But I tend to have I'll have limits. So if someone comes along and go, "Hey, we've got a replacement for this that you can drop in," great, brilliant, runs cool, brilliant. Your machine's no longer melting, does the same job. More stable power supply, even better. I'll take all of those benefits in games. You know, that kind of win is a win for me. Straight out the gate. Yeah, screw you. Following controls the piezo location. Observe the polarity. Yeah. Plus that side. The legs are the same length. Its length shows the positive terminal. Two. There we go. That was easy. If you plan to clean the board with Flux Remover Isopropyl, do not remove the label until after cleaning. Fair enough. We shall leave the label in place. Oh. Jumpers and bus. Following board drawing shows jumper header locations. Place the components as shown. Two-way header, three-way header. Ready for chip tunes. Yeah, terrible chip tunes off this thing. Three-way header, two-way header. What about you? There's a couple of you. Choose. Okay, take the 3 pinners. Oh. Okay, so 3 pin up there, that's fine. 3 pin up there, that's also fine. Expect that, expect that. Expect all of them. 2 sets of 2 pins on the Z80 clock. Right, fine. Two sets of 3 pins on the high-low. And then this one down here. Dokes. Aren't orientated correctly, so you can have a change. Oh. Now we're going to get you to turn over. Okay, that's just 2 sets of 3. A little rude, leave the map just there for the moment. The thing just there for the minute. Unshit. Can we stay unshit, please? Thank you. Good. Isn't there another cluster down here somewhere? Probably. Yep, lost you. Oh wow, wonky as hell. Right. You should be horizontal. Okay, so that one looks pretty straight. Those two look pretty straight. Yeah. That one looks straight. This one is kinkier. Nope, I lied. Wow. Also you again. Okay. Straight to those two. Pretty good. Yeah. Just you, monsieur. Determined to be a sod. Just tap the one at the back. Yep. Run around and solder the pants out of everything. So much soldering. Good. That's done, that's done. That's done. That's done. Okay. Do you remember jumpers, folks? Some of us do. Ugh. Right. So PAL or NTSC? Well, PAL, because PAL. It's easy. It's a very stiff jumper. Right, that's off. Normal or inverse? The inverse normal sets the video mode. The Z80 and Z81 use normal mode. The Jupiter Ace used inverse mode. Well then, use inverse mode. It's a Jupiter Ace, folks. Okay. ROM address jumper settings. ROM address jumpers A14 and A15, these two over here, set the upper address lines on the ROM chip. If programming your own ROM chip, you can select from multiple ROM images using these jumpers. The 8K ROM images are placed at the bottom of each 16K block. Use the following settings with the supplied pre-programmed ROM chip. 4th, standard 4th ROM. So Select a 3.25 MHz clock when using the 4-ROM if sound or tape access is required, as the timing of these functions requires a 3.25 MHz clock. The video circuitry is fixed at 6.5 MHz, so the video signal will always be at the correct speed regardless of the CPU speed. Z80 clock jumpers. Use these jumpers to select which internal 3.25 MHz or 6.5 MHz clocks or RC2040 bus clocks are fed to the Z80 CPU. The selected clock can also be fed to the RC2040 bus to drive other clock cards. One jumper on its own. There we go. Minstrel 40 of Z80, 3.25 MHz. In these modes, the Minstrel 4th clock signal is fed to one of the clock pins on the RC2014 bus. Do not use any other clock modules. So you can set so it sounds like what you'd want to do is that and that by default. So, Z80 clock speed at 3.25 MHz, RC2014 clock 1 set to 3.25 MHz as well. What I'll do is I'll offset that by 1 to start with, and then we can put it back onto that pin if we're happy. We've not got anything for RC2014 at this point. Power polarity jumper settings. Wow! You can actually change your power polarity, which is brilliant. Okay, the jumper block near the power connector sets the polarity of the power input. Power requirements are approximately 9 volts DC. Current consumption is approximately 70 milliamps for the board itself. The use of the expansion port increases consumption. Center negative. Used by the optional power supply. Also, and Spectrum and Commodore 16 computers. Center positive, used by most other power supplies. We'll be going with center negative because ironically it's the most dominant power supply on my desk. Which is 2 jumpers horizontally. I do like that. And it even has a graphic on the motherboard to tell you which one's which. Most of the other jumper positions, you have to look in the manual, but still you don't screw it up. Your polarity is marked on the board. Two horizontal, center neg. The board can be powered from the RC. No! No PSU protection diode or polyfuse. No! The only reason I laugh is that's how you usually blow up one of these. But yeah, no, you tend not to get them. Yeah, basically, same problem. After a while you just get good at looking first. Look before you leap. Oh. Allowing you to omit or ignore the DC jack polarity jumpers. Right, hang on. The board can be powered from the RC2014 bus. It's quite nice. Allowing you to omit or ignore the DC jack, polarity jumpers, the 22 microfarad capacitor, and 7805 regulator. If using multiple RC 2014 cards, consider using a powered backplane rather than the DC jack on the Minstrel 4th. Jacks! Or a full bridge rectifier. I'm not getting into bridge rectifiers. At that point, we're crossing over into the no man's land. I'm not doing that. Okay, jack locations. Ear mic. Ear mic. Power. You puny half bridge. I've only ever known a full bridge rectifier. I'm going to ask a really stupid question. Is there such a thing as a half bridge rectifier? Stupid question time. Then this one. Okay. I mean, there's a bit of me that says, well, no, there can't be. Yep, one diode. Oh, okay. Yeah. I don't think I've ever seen one. This is getting increasing in height stuff. Oh, I don't need you anymore. Oh, I might do. Oh, I haven't put jumpers in, and the jumpers are higher than the jacks. In fact, the jumpers are a pain in the rear. We'll be with you in a sec. Okay. Much bigger cat, more ripple. That makes sense. We got a flat first time. Jesus. Gonna get lucky once. Zinky. The other thing I do like about this iron is it will just sink heat. Okay. Barrel jack. Beautiful. Nom 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 nom. Eat up solder. Here we go. Ah. Right. I had it. Have a look on the other side. I reckon we got that. Is it going anywhere? No. Good. Okay, Jack's done. Jack's Divine Retribution is done. Keyboard assembly. Switch placement for the Minstrel 4th keyboard. Oh my god. Right. I'm not saying I'm dreading this one. But, oh! A lot of those. Okay. Insert each switch into the board, aligning as shown below. Do not solder the switches into place yet. Fair enough. You want horizontals, don't you? Yeah, go Froggy. 1, 2. 3. I think that is a potential option for a keyboard interface. I think. Yeah. Yes, it is. Looking at it from the underside, you can see it's coming up through here, but that does give you another pin-out option. So, providing an alternative should be very doable. I know someone's working on a USB keyboard adapter. Using a microcontroller, which is nice, but I mean, behold all of the keys, and behold the key switches and the matrix is already there. I think you can just make a bigger one, and add in some cherries. Doesn't need to be perfect, just needs to be what, creating a cherry keyboard for one of these? Or the USB bit? Show you what I'll tell you about projects that are really wrong but are also really good. Converting USB to matrix. It's not an unpopular thing to do. Not unpopular. Yeah, it's quite a popular trick. There's a really nice project that takes the rubber key specky and adds little micro switches underneath the dead flash. So if you've got a dead flash keyboard, you can micro switch it up and suddenly get a much better feeling keyboard. Something I'm very tempted to do at some point in the next few years is, because I'm never going to get a 128 in sensible money. And I'd quite like a 128, not a +2, an actual 128. Yeah, I shall not grace anything with Amstrad in this house. But I do quite fancy the Harlequin project, which is a rebuild with the ULA and discrete components. And they do a 48K and they do a 128K version. And I quite like. The interesting thing is they are both designed to fit in the rubber key case, not just the 128 isn't just required to fit in a plastic toast rack case. So I quite like the idea of making a 128K supercomputer, as it were. So making a Harlequin, sticking on a Xilex, I think it's Xilex, sticking on the microswitch keyboard with it anyway. Probably keeping the existing RGB out. I've got enough peripherals. Hello. We don't believe in spares. I appear to have a spare. I have not. That sounds interesting. Oh. Okay. Do not solder the switches in place yet. Insert a screw at each corner of the keyboard overlay. And screw on the spaces to hold them into place. So this is the keyboard overlay. And screw on the spaces to hold them into place. Okay. Screw at each corner. The spacer. Screw. Spacer. Remount the remaining 2 pillars and screws. Oh, hang on. We're not quite there yet. Okay. Place the keyboard overlay over the switches. Yep, done. Secure the 4 corners of the overlay with the pillar. shown below to ensure all switches are held in the correct position. I mean, those switches weren't going anywhere anyway. If you like, you can solder the switches, but it's not usually necessary as they make good electrical contact, as they're held firmly in place and make good electrical contact. You know what? I think we won't solder the switches. I see 3 asterisks. Count the remaining 2 pillars and screws the hole in the back of the board. I'm laughing. Yeah, easiest to replace, providing it works. Pretty positive. Just, I mean, I have tiny hands. That's already tiny. It does not. Ah, gotcha. Thank you. Hey, did we miss the bit where we were supposed to add the RC 2014 header? We did. It was way back here. Ugh. Okay. It's past the IC socket step. I was getting lunch there. They'll pay more attention than I am. I mean, luckily it's an easy fix, right? I'm happy with that. It's connected up. That's gonna need some cleaning. Did I bring a toothbrush out? I say toothbrush, nylon brush. I did not. Okay. If this is the must read all the things. If this is the only step we've missed, I'll be amazed. Okay, RC 2040 bus in. It is another kit I would like, the RC 2014. Oh, platform to explore anyway. Okay, see how it fits. Yeah, feels nice. I mean, those are more positive than the freaking Spectrum Plus keys. Okay. Socketed ICs. Do not remove the ICs from the protective foam until soldering and cleaning are complete. Fine. Really not bring a nylon brush? Making more mess than not. Right. I will be a second. Okay, things that we are done. We are done with soldering. Clean your tip spokes, else they'll come back and haunt you in a second life. Okay, let's kill that. I'm going to pop out and go grab a nylon brush so we can give this a very careful and quick scrub. I'll be back in a minute. We're back. Give this board a quick clean down. Carefully. shit. Right, well, that's going to need redoing. Check your own video for which number it is. Yeah, I mean, I can get the number, so I can write it back down again. However, this is getting stickier. Oh my god. Never had so much problem cleaning flux off. Feels better. I want to just give it a third rinse down and then we're okay. We'll see in a sec. So dry first. We've got stickiness in the bottom left, so that needs a clean. Yeah. I want to put the chips on! What is it? I know I've got to clean my board. So where are we up to? I mean, it is just fit sockets at this point. Fit chips. And then hope, pray, and test. Yeah, one more round. You can see as it's drying that there's still just that little bit tackiness left, but it's definitely getting there. Oh. And, you know, all the alcohol on this side. Okay, one last round of alcohol. No, I didn't just admit the alcohol, honest. How was your New Year? Good enough to be sniffing the alcohol. Boozing, really boozing. Proof? So how much for an ultrasonic cleaner? let's let that dry. No, but they managed to get as it dried last time, some of the alcohol containing the flux moved over the keyboard and dried, leaving a sticky residue. So that last one was just to try and flush that out. Yeah, it was sticky on the edge connector. This one is just... I don't remember this solder being this much of a problem for cleaning. It's a no clean flux, it's not the rosin flux. That might be why. No, it's leaded. It's lead flux, but it's lead no clean flux, as opposed to the usual the stuff I've used previously. Which is proven to be a bugger to clean. We're getting there. Yeah. Got some here, still got some here. Still got some along the edge connector. I want to turn this on. But we're still flooded. Jesus. We are just waiting on that to dry. What do we lose? What's that one? There we go. Right. Chips will indeed need a little bit of loving to get them in. So let's work that out. Here's a big fat note. Great enough. A little more. That side. A little more persuasion. Good grief. Much more persuasion do you want to give it? Not enough persuasion, too much persuasion! Still not enough persuasion. Enough persuasion to launch its own TV show. There we go. One in. Still got stickiness. Problem for later. You have to go in with Q-tips around there. Okay. Number 2 in. I'm persuaded that it's in. Is this? I mean, we're still on the royalty-free chill music. Supposedly. This is a track called You, but that little lick in the middle, it's got some distinctive overtones of, oh God, what's it? Destiny's Child, I'm thinking of? you went straight in, no problem. You went in, no issue at all. Okay. Right, that is it complete. All the chips are in, everything's soldered on. I definitely want to give that another freaking clean. I will do it with buds, because no more for now. Let's try and hook this up and give it some juice and see what happens. There's a juice loose inside the hoops. This thing. Bring that across. Hit all the things as we go across the deck. Thank you, I appreciate fingers crossed. So this is power supply that was originally bought for the Specky. Then we realised we had a few issues with it for the Specky. Oh. So we're currently using the original power supply for the Specky. But it works great for the MT32, so it's currently running on the MT32 duty. Right, overkill on the video cable. Let's add in an existing video capture device. Okay, let's give it some welly. It did go bang. Deactivate, activate, configure video. Right now that doesn't mean bunkers. Turn you back off. I don't like the fact that you appear to be hanging out. You're in enough. Why can't I get you to initiate? Okay, let's do a switch over. Turn off the game cover for the minute. Now it's going to talk to me, so that's good. Composite. Oh, that's actually pretty positive. Yes! Oh. Okay. Let's pause Spotify for a minute. VList? VList. So this is the list of all built-in commands. Yeah, you get a cursor. So this isn't keyword based. This is this involves a full parser, and the best way of thinking about it for the minute is reverse Polish notation, but it's stack based. To be quite honest, have you worked in Forth at all? So let's do 100. This the manual tells you. So that is exactly what we would expect to see. Perfect. That is the list of keywords, the dictionary list that it currently knows. Perfect. 100. Where's the space? There. 100. Beep. It made a beep! Let's go grab a hello world. No, not Fortran. Forth. That's right. cr.hello world. cr. Ugh. Yep, we're not touch typing in this. Yes. So the word cr, carriage return, causes the output to be displayed on symbol shift on a new line. The parsing word dot quote reads a double quote delimited string and appends code to the current definition, so the parse string will be displayed on execution. Symbol shift P. Hello. I'll need a symbol shift. Base. World. Hell on world. Close enough for the moment. Bomb. No. Is that enough? It is not. You're correct. Symbol shift bomb. I have a book that's upstairs. Yeah. Typing at the keyboard, blah, 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 blah. Loading programs from tape, defining new words. Simple arithmetic. So take the top two things onto the stack and add them together. I don't want to define new words right at the minute. I want to... Oh, yeah. Let's make it really easy. Okay. Dot. Open. Oof. Hello. Base. Symbol Shift P. That should be enough. What did I miss? What the hell did I miss? CR dot will. Right, okay, fine. I don't remember having to define, because I played in here before. So you define new words within the language. That's what makes this interesting, is stuff exists in words. So hello dot hello world. Symbol shift bam, symbol shift bam, and the semicolon to end it. Okay, enter. It will keep telling. Why do I keep going the question mark? Okay. Need the space. Didn't think we needed the space. Symbol shift semicolon. Well, at least we got an error. Two plus. Parameter 2. So 2 space 2 symbol shift plus 2 add. Yeah, well done. Dot. Forgot to dot. Right. Two space plus 2 gets pushed onto the stack, 2 gets pushed onto the stack. The plus operation takes the previous 2 things that are pushed onto the stack and does something with them. In this case, adds them and pushes the result back onto the stack. The push space, the dot operation then takes that and takes whatever's on the stack and displays that onto the screen. 4. Correct. Okay. Symbol shift P. Hello. Gets pushed. Symbol shift P gets pushed out onto the stack. Yep. Space. The dot operation will then take that from the stack and display it onto the screen. Nope. I can't remember. I've got a sneaky feeling it does not. And that was a deliberate design choice. Strings and Arrays, Chapter 21. A string has no such meaning. For pleasure, you print strings by using dot, but many computer languages like to manipulate them in all sorts of ways. So doesn't do anything because it needs the thing in advance. Okay. Let's go with this example. Space. Hello. For the very hungry caterpillar, I can't argue with that. Okay, so this starts a new subroutine, or a new function, which consists of a number of operations. CR will adds a new item onto the stack. Thank you for popping by and sticking with us whilst we went through that. That was a lot of work. Your company was very appreciated. 16 space 0 space do. Okay. I space 1. No. I space 1 space color, spelt American. Okay, I need a break. I think we're going to leave that there. I can get the maths bit working. I can remember how to do maths. So I can do things like things get added onto a stack. It's close to RPN, so 2 space plus. Take two operations, stick them off the stack, add them together, and then spit them back out. He says hitting the wrong buttons. But I have not yet eaten today, and I am starting to now feel a bit woozy. So I am going to leave you with 2 plus 2 does indeed equal 4. Go and grab some lunch, and then come back and play with this later, and get my head into a bit more of it. And I thank you very much for your time. That's a machine built. That's the Minstrel 4th. Next time we see this, we'll hopefully have some bits of 4th to go and play with. But yeah, I think that's enough progress for now. Okay, thanks very much. Thanks for dropping by. You've been very. Your company has been most appreciated. Okay, we should go and say hello to somebody. Let's go have a look and see who we can. Who's around today? Neil's streaming. Wow. It's the middle of the day. Bloody hell. Okay. Well, let's go raid Neil. Going and raiding RMC Retro. Let's hope it's over there now.